Okay, let's do something fun. Let's move a robot to pick up a block and put it back down. And this shows off a couple things. One is motion planning, inverse kinematics. So let's just see it in action, and then we'll come back and explain what happened here. And again, all these examples are available to you. I like to go through the actual documentation rather than just run the example and kind of build it on my own. That way I can understand what happened. You can see here the robot picked up the block, and that is all. So let's make a few modifications and run it again. And then I'll explain what I needed to do to get to this point. It's super simple. Again, all the examples that you can see here on the left, I tend to run these myself, kind of put it together myself. That way I understand exactly what's happened and all the code. I just don't like to copy and not understand the code. Didn't really learn anything that way. So here we go. I think this is more in line with the example shows. So it picks up the cube and then stops. Okay, how do we get here? Super simple, but there are some steps. So I just want to kind of briefly walk through what the steps were. First step is to download and build this package on PL, which and it's the Open Motion Planning Library. And what you'll notice about it, it's been used over the years, many years by many different tools. I think tools like Move It by Picnic started out with this, or maybe vice versa. Who knows how it worked? But you can see here, this is a way to kind of understand inverse kinematics and moving an end effector to a place and location. So you use the Open Motion Planning Library. How you install it, at least for me, on Linux, is I found my Ubuntu version 3.1, and this is the wheel, pip install. Also experimented with trying to have, I use all of these coding assistants, so I have all of them, if you can imagine, and I tried to see if GitHub Copilot could run this with continue, build it all by itself. Almost worked, came very close, but then just fell slightly short. But it did have all of the steps and did all of the steps, just did not complete it, did not look through its errors and try to correct itself. But anyway, so let's just run through the documentation real quick, and then we'll call this one done. So here we are, inverse kinematics and motion planning. What we're doing is showing the viewer, creating the scene, nothing new. Here we're setting the forces and force ranges for the array. I think it's 9-item array. There it is. And from there, we're going to specifically get the end effector, and this is where we're going to set the position on the end effector, and and path plan using just as the end effector is what we're trying to path plan using just that. Then we're going to go down and pick up the cube. So now this is actually not using any kind of real, what would you think of like reinforcement learning to pick up the cube. What it's really doing is saying, okay, go to this position, pick up this exact object. Kind of like the old school car manufacturing automation, where you would just send the big giant robotic arm to a location, not knowing exactly what's supposed to be there, and pick up the object and move it, etc. I call this dumb robotics, and so what we did for 50, 60 years. Kind of what disinterested me in robotics for a while after going to school for mechatronics. So I'm going to leave this one here. That's probably good enough for now, and we'll jump into, matter of fact, maybe on the tail end of this, let's look at rigid bodies real quick, because I thought it was interesting just to take a look. It is part of my use case, but not really at the moment. So let's just quickly just run through this. I want to actually even go deeply into this until later. We do have a use case where we're going to try to pick up a toothpaste container, and that's a deformable body as well. So we will have to do that at some point. For today, we're just kind of showing off the end result, end state. I think I have another one too. Yeah, here's another one. And I think these are all, like I said, these are all examples that you can find in the example repo. I just built them myself because I was really, trying to understand what's going on in detail. And here you can see it's showing the links as it's moving around. And at some point, we can build something to grab these and provide that motion on our own. And I guess let's look at NPM real quick, and then we'll stop for today. Again, these are all available as walkthroughs. Kind of glossing over some of these because I'm really focused on robotic control and with reinforcement learning. In the wrong window. Hurry. There we go. So here, this is got solid bodies and now in a liquid. I think it's supposed to be plastic. So you can see the plastic, it's kind of floating and moving along. And we can get into detail on this, but I don't think it's worth it right now. But you can go through here beyond rigid bodies, etc. And so today we're going to try to pull this one out and these two, and we'll call it good. One other last thing, since it's going to be an extra long video, I do enjoy the debug, and to be able to debug my scenes. And this is a way to debug your scene. I don't know if you ever use IPython, but you probably have if you ever used Jupyter Notebook. You get the Python visualizer right there. So here now I can say something like, let's just make this big, and I can say like, okay, show me the scene, and it's going to show me all the items in the scene, and I can drill down into any of these subsets. Like I can say, show me the robot, which is part of the scene. Basically anything that's been added to the scene. So if I look up here, this is super simple, but I have a scene, I have a robot, so I can say, give me that, give me the plane, give me the robot, give me the camera, blah, 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 blah. And then, and I can see here, these are all the links within this Franker robot. Really cool. And you can see it went up to the, there's the scene. This is the robot. And then I can do other things like, show me the links. Show me the joints, each joint. Show me joint 0, and then kind of drill down deeper. And it's good for debugging purposes. If you're missing something's not working, this is a good way to take a look. So this is kind of a longer video with a few of the things that are going on. All of these, again, are available in the GitHub repo. Here's some examples. It's probably going to be updated all the time. Here is the tutorials that we're going through right now. And I purposefully have not looked at these in detail because I want to run through them myself. Okay, well, thanks. It was a good one today. A lot of different content. So I hope you enjoyed it.